Okay, welcome to IGCSE and A-level chemistry classes. In this video, we are going to discuss about past paper 4. Past paper 4 related to electrochemistry. Okay, today we are going to discuss about past paper related to electrochemistry. Here, first question, we have to discuss question number 6, May June 2007, question number 6. Okay, so this question related to electrochemistry. Here, aluminium is extracted from alumina. The ore of aluminium, in the question it is given, the ore of aluminium is bauxite. Ore of aluminium is bauxite, okay, which contain alumina. The formula of alumina is Al2O3. The formula of alumina is Al2O3. Clear? Here, the ore of aluminium which contain aluminium oxide, that is alumina. Alumina is amphoteric in nature. It is given here, alumina is amphoteric in nature. Amphoteric. Also, the ore which contain iron 3 oxide. Iron 3 oxide, which is basic. Iron 3 oxide is basic. Okay. To get aluminium from bauxite, the ore is heated with aqueous sodium hydroxide. The ore is heated with aqueous sodium hydroxide. Okay, based on this we have to complete over here. Okay. To complete this, you have to know a basic information about acidic, basic and amphoteric substance. Okay, so here it is given bauxite. Bauxite, it is bauxite which contain alumina. Alumina formula Al2O3. Okay, it is amphoteric in nature. Also, alumina which contain iron 3 oxide. Iron 3 oxide formula Fe2O3. It is basic nature. Basic nature. Okay, look here. You must remember, acidic and acidic substance do not reaction. No reaction. Acidic substance, no reaction. Acidic and alkaline substance react. Alkaline and alkali substance together, no reaction. Okay, but remember, amphoteric substance react with acid. Amphoteric substance react with alkali. Clear? Remember this. Based on this, look here, based on this, here it is given in the question Al2O3. Al2O3, it is amphoteric substance. So, amphoteric substance. Okay, Fe2O3, it is basic substance. We are reacting with aqueous sodium hydroxide. Aqueous sodium hydroxide means we know it is alkali. Sodium hydroxide, it is alkali. So, Al2O3, it is amphoteric. Amphoteric substance react with the alkali. So, there will be reaction. Okay, and Fe2O3, it is base. Okay, alkali or base. Okay, there is some difference in alkali and base, we will discuss later. So remember, base and alkali, no reaction. Same like alkali, no reaction. Okay, base and alkali, there is no reaction. Clear? So based on this information, we can solve this question. Okay, so here we know ore which contain alumina and iron 3 oxide. So which one dissolve? Alumina will dissolve. Okay, dissolve mean something which reacting, that will dissolve. So alumina reaction, alumina will react. So alumina will dissolve. Okay, after dissolving, alumina dissolve in sodium hydroxide and form sodium aluminate. Clear? I told you in the beginning, alumina, it is amphoteric. It will react with alkali. Okay, so you can answer here. Alumina dissolve in sodium hydroxide and form sodium aluminate. sodium aluminate. Okay, and here next one, does not dissolve. Does not dissolve means something do not react. Okay, I told you iron 3 oxide or iron 3 oxide. Iron 3 oxide does not dissolve. Okay, so in aqueous solution, in solution something not dissolved, so this can be separated by, how can you remove undissolved solid? You can remove by undissolved substance, you can remove by filtration. So you can use filtration to remove unreacted or undissolved iron 3 oxide. Clear? Next one, we have to fill this diagram. We have to label this diagram. Okay, this type of diagram in your textbook. Also we discussed this diagram in our lecture. You can watch the lecture, electrolysis of molten compound. Here we discussed this one, extraction of aluminium. Okay, so watch that video. Okay, here this diagram based on that extraction of aluminium. Okay, so you know, during extraction of aluminium we will use a steel container. Okay, steel container, the inner part of steel container coated with a carbon or graphite. Okay, inner part of steel container coated with carbon, it is act as cathode. So here we have to label this. So this is inner part graphite, it is carbon cathode. Okay, here big blocks of carbon is inserted into this container. So this is carbon anode. These big blocks are carbon anode. Clear? And here electrolyte will be mixture of aluminum oxide and cryolite. Here mixture of aluminum oxide and cryolite. Okay. Why we use here cryolite? Cryolite, it helps to reduce melting point of alumina. Cryolite helps to reduce melting point of alumina or aluminum oxide. That's why we using here cryolite. Cryolite mean Na3Al(F6). Na3 sodium, Na3Al(F6), that is cryolite. Clear? And here at the bottom part, at the bottom here, look here, you have to label this. It will be molten aluminum. It will be molten aluminum. Okay, and here temperature will be 900 to 1000 degrees Celsius. 900 to 1000 degrees Celsius temperature, because we used here cryolite. Okay, without using cryolite, temperature will be around 1500 degrees Celsius. Okay, after using cryolite, temperature decreases to 900 to 1000 degrees Celsius. Okay, clear? Okay, last part of this question, you have here question saying write the equation at carbon cathode. Okay, look here, to answer last part of this question, you have to understand here this one. Look here, we talking about aluminum oxide. Okay, aluminum oxide Al2O3. Okay, at a high temperature Al2O3, it will be Al3 plus 3O2 minus. Here, you know, using periodic table, you know, aluminum 3 plus, oxygen 2 minus. You know the charge of aluminum and oxygen from the periodic table. So Al2O3, it will be Al3 plus and O2 minus. Here Al2O3, so 2 aluminum. So we have to write here 2 Al3 plus. Okay, O3, so we have to write here 3 O2 minus. Okay, you just understand, no need to answer this over here, but later onwards or in future you have to solve such type of question, but you understand here how to write this balanced equation. Also you can see different past paper, you have to answer this type of question. Clear? So you understand all this, not only particular question. Clear? So here there is cathode and anode. So you have to write here cathode. Okay, you know cathode negative charge and anode positive charge. So cathode negative charge. So positively charged ions coming towards cathode. Okay, so Al3 plus coming towards cathode. So Al3 plus electron giving Al. You remember reduction taking place at cathode. Reduction taking place at cathode. Okay, reduction mean at cathode always it gain electron. Gain electron. Clear? You can remember very easily here Al3 plus, okay, here 3. So 3 electron getting Al. Sometime you have to solve this type of equation. Cu2 plus, what type of reaction take place? Cu2 plus also reduce at cathode. Cu2 plus will attack on cathode. Reduction takes place. So how can you complete the equation? Cu2 plus reduction. Reduction mean plus electron. Here how many positive charge? 2 positive charge. So 2 electron giving Cu. If there is one positive charge like Na plus, okay, so how can you complete the equation? Here one positive charge, so 1 electron giving Na. Okay, so you can answer this type of question like this. See how many positive charge, same number of electron, change to same element. Here this side no charge. Clear? So you can write the equation at the cathode. So here this is the answer. This is the answer. Here the question asking here, write down the equation at cathode. So we know cations are coming towards cathode. Here cation Al3 plus. So Al3 plus 3 electron giving Al. Clear? Also you understand over here, O2 minus is anion. O2 minus is anion. Okay. O2 minus is anion. So which one coming towards anode? Anode, you know anode it is positive charge. So negatively charged ions are coming towards anode. Okay. So here O2 minus coming towards anode. Okay. Also remember oxidation takes place at anode. We discussed reduction taking place at cathode. Reduction mean gain electron. At cathode reduction, at anode oxidation. Oxidation mean lose electron. Here oxygen lose electron and change to O. Okay. Here O2 minus, I told you before, here Cu2 plus 2 electron. Cu2 plus receive 2 electron. Na plus receive 1 electron. Al3 plus receive 3 electron. Similarly here you understand here O2 minus, so 2 negative charge, so it lose 2 electron and change to O. Okay, but we know oxygen it is diatomic elements. Diatomic elements mean you know O2, N2, H2, Cl2. Okay, this type of elements, all halogens are diatomic. Okay, F2, Cl2, Br2, I2, also H2, N2. This type of elements are diatomic. So we must write here 2, not O. We have to write here 2. That means you have to multiply complete equation with 2. 2O2 minus 2 times 2, 4 electron O2. Okay, oxygen. So this is the reaction taking place at anode. This reaction not asked here. You have to write this equation only. But you understand here what type of chemical reaction taking place at anode. Clear? So O2 minus attach on anode and it produce oxygen gas. O2 minus lose electron. Oxidation takes place and change to O2. Clear? So remember oxygen gas formed at anode. Okay, so here the question asking here, explain how carbon dioxide formed anode. This is the question. To answer this question we discussed here, these are the big blocks of carbon anode. Okay, anode is made of carbon. And also I told you now oxygen gas formed at anode. Okay. So you have to say carbon anode reacted with oxygen formed carbon dioxide. Carbon anode reacted with oxygen formed carbon dioxide. Okay. This is the answers of this question. Okay, next one, same question, part D. Okay, here we have to explain why aluminum used to make aircraft body, why aluminum used to make food container, why aluminum electricity cable contain a steel core. So here first question, why aluminum used to make aircraft body? Okay, manufacturing of aircraft, aeroplane parts, which aluminum used. Okay, because aluminum has low density and it is very hot. That's why aluminum used to make aircraft part. Aluminum has low density and it is hot. Okay, next question, second one here, aluminum used to make food container. Aluminum used to make food container. Why it used to make food container? Here aluminum, it is malleable. Aluminum we can change to thin sheet. Aluminum is malleable. Also aluminum do not attack with the heat or chemicals. That's why aluminum used to make food container. Okay, on the surface of aluminum there is aluminum oxide layer. It is hard and strong. That's why it do not attack with the heat and chemicals. Here 2 marks, so you write 2 points. Aluminum is malleable. Also it do not attack with the heat and chemicals. That is the answer. Third one here, aluminum electricity cables contain a steel core. Look here, this figure, there is aluminum cable and showing a steel core. So this steel core giving a good strength and support for aluminum cables. That's why used. Okay, here steel core giving a support and strength to aluminum cables. Okay, that's why steel core is used. Okay, next one we have to discuss here, May June 2008, question number 3. Question number 3. Okay, so this question related to extraction of copper, or you can say refining of copper. Okay, to solve this question you have to know refining of copper. Okay, so in this figure it is given here aqueous copper sulfate. This is electrolysis of copper sulfate using copper electrode. Also this is in the video, you can check the video. Okay, electrolysis of aqueous copper sulfate. Here electrolysis of aqueous copper sulfate, electrolyte, we use aqueous copper sulfate. And here there is impure copper and there is cathode and anode. Cathode is impure copper, cathode is thin pure copper. Okay, this is cathode, cathode is thin pure copper. This is anode, anode is impure copper. This is this figure showing electrolysis of aqueous copper sulfate using copper electrode. Here this is electrolyte, electrolyte is aqueous copper sulfate. Aqueous copper sulfate means copper sulfate dissolved in water. Okay, this is impure copper, it is anode. Okay, thin pure copper, look here, this is copper, it is very thin. Okay, it is cathode. Clear? When we pass electricity, there are many possible reactions. Aqueous copper sulfate mean aqueous represent water. Aqueous mean water. Okay, so water after passing electricity it will change to H plus and OH minus. Copper sulfate when you dissolve in the water it will change to Cu2 plus and SO4 2 minus. Okay, so there is H plus and Cu2 plus, in electrochemical series Cu2 plus is down. Cu2 plus is down 1. So Cu2 plus will deposit at cathode. Cu2 plus it will deposit at cathode. Cu2 plus receive 2 electron and deposit at cathode. Cu. Okay, reduction takes place at cathode. We discussed in the previous question. Okay, at anode there are 3 possible chemical reaction at anode. Look here, there is OH minus, there is SO4 2 minus. Okay, so there is three possible reaction. Okay, OH minus will attach on anode. SO4 minus, SO4 2 minus also attack on anode. Also look here, this is electrolysis of aqueous copper sulfate and copper electrode. Okay, we inserted copper electrode in copper sulfate solution. So there is a tendency, strong tendency, carbon anode lose electron and it will change to Cu2 plus. Okay, so here carbon anode is, sorry, it is copper anode, not carbon, copper anode. Okay, copper will dissolve in solution, copper lose electron and it will dissolve in the solution. That's I did here. At anode, copper mean it is copper anode lose electron and it will change to Cu2 plus. So this Cu2 plus will dissolve in the solution. So these are the chemical reaction taking place at cathode and anode. So remember here at anode reaction, what type of chemical reaction takes place at anode? Carbon anode dissolve in the solution. That is the reaction. Okay, this is the equation. Carbon anode lose 2 electron and change to Cu2 plus. So this is the this diagram showing refining of copper. Refining of copper means purification of copper. Here at anode it is impure copper. At anode it is impure copper. After passing electricity, here all copper will deposit at cathode. All copper will deposit at cathode. Finally, you will get a big pure copper at cathode. Okay, I told you at anode copper will dissolve into solution. This copper will deposit at cathode. So finally, all impurities will settle down here and anode become thin. During this process, anode become thin and cathode become fat. Clear? Now you have to answer based on this information. You can simply answer this question. Okay, so the copper is here, the question saying based on this information you can solve this question. You can solve this question very easily. Look here, this question related to purification of copper. Copper can be purified by electrolysis. Okay, we have to complete this one. Okay, so here during purification of copper, the positive electrode, anode is impure copper. We discussed anode is impure copper, and here cathode is made up of thin pure copper. Okay, and electrolyte, it is aqueous copper sulfate. Aqueous copper sulfate. Okay, so here anode impure copper, cathode thin pure copper, and here electrolyte aqueous copper sulfate. Here next one we have to write the equation at anode. Anode we discuss, anode is made up of copper. This copper lose electron and copper anode will dissolve in the electrolyte. We discussed already. So you have to write Cu minus 2 electron giving Cu2 plus. This is the reaction at anode. Okay. Next one here we have to say why copper used in electric wire. Okay, in electric wiring copper used. Why? Because copper is good conductor of electricity. Also copper is ductile. And it is good conductor of electricity. Ductile mean metal can change to thin sheet. Metal can change to thin wire. Metal wire, that is ductile. So copper is ductile, also good conductor of electricity. That's why copper used in electric wiring. Okay, next question here, why copper used in cooking utensil? Why copper used to make cooking pot? Copper used to making cooking pot because copper is good conductor of heat. Copper is good conductor of heat. It is thermal conductor. Also, copper can change to different shape by applying high force. That's mean copper is malleable. Malleable mean metal can change to different shape, or you can say metal can change to metal sheet. Okay, metal sheet. Okay, that's why. So here second answer you have to say why copper used in cooking utensil, because copper is good conductor of heat. Also copper is malleable. Copper is malleable. Last part of this question, give another use of copper. So here we discuss copper used in electric wiring, copper used in cooking utensil. Here another one, you can say copper used to make alloy. Copper zinc alloy, it is called brass. Okay, so you have to say copper used to make alloy. Alloy mean mixture of metal, mixture of copper zinc alloy, it is called brass. Okay, so these are the answers of this question. Clear? Thank you for watching this channel. Okay, so please subscribe this channel. You can share to your friends, like, and watch next video. Thank you. Thank you for watching this channel. Please subscribe and press the bell icon for more videos. Thank you.